Hi, so in this video, I'm going to first explain how do you find the surface area of any prism, and then we'll go back to this question. First of all, prism is any solid. The in the O levels or in the middle years program, it's any solid which has a consistent cross section. Consistent cross section. Cross section is also referred to as a base area. What do you mean by consistent? It means that the shape is not changed and the size is not changed either. As you can see, this cylinder is a prism. If you slice it horizontally like that, if you slice it horizontally every time, what is the shape that you always get? You'll get always this circular cross section. We'll call it the circular base area or circular cross section. Hence, this is a prism. And for any prism, the trick is you find the base areas. So it has one and two base areas. I'm going to use B dot A as short for base area. And then we have this curved side. How do you find this curved side? Well, the trick is you wrap all the other faces except for the base areas. You wrap all the faces with a rectangular piece of paper. And when you lay it flat, look at this. I'm going to mark with red. The red length will be the length that is fitting exactly on the cross section. This length is fitting exactly on the cross section perimeter. So we say perimeter of the base. I'm going to use POB in short for perimeter of base. This red line is fitting exactly around the cross section. And the height of this prism is actually the height of this rectangular portion. So that's how you make a formula in the most generalized way for surface area of any prism. And through this cylinder, we can use this formula to any of the prisms. It could be a triangular base prism, it could be a rectangular base prism, or any other prism. The formula stays the same. Now you have to be clever in using the formula also. Let's see. Explain why the area of tin plate needed to make the cylinder is given by the formula this. And at the top, it's a hollow cylinder. If it's a hollow cylinder, it means it doesn't have any of these base areas that we used. So we will use the same formula for part A, and it doesn't have base area because the top is not covered, the bottom is not covered. It's a simple hollow cylinder. It's a pipe. Perimeter of base, it's a circle. Perimeter of base will be 2 pi r. And the height of this prism is given by h here. And that's as simple as you like, 2 pi r h. Now that being done, in part B, how can this formula be adjusted to find the total area of tin plate needed to make an open bin? Now, open bin of radius r, open bin means it doesn't have one of these cross sections, but it does have this base area. It means instead of two base areas, it has just one base area. So one base area is a circle, so pi r square. We used one base area here, plus the perimeter of base, which is 2 pi r, the height of the prism, which is h, and thus our formula is pi r square plus 2 pi r h. Or you can use pi r as common out, you'll be left with r plus 2h. So this is the adjustment that we can make for part B, for an open bin. Up next is find the area of the tin plate used to make an open bin with a base radius 15 and height 40. So this is quite straightforward. You have already devised a formula for an open bin, and you just need to plug in the area needed for an open bin which has radius 15. So it's pi times 15 bracket 15 plus 2h, which is 40. The height is 40. I'm going to expand this bracket, where the BODMAS rule says bracket first, you solve within the bracket first, and then you go otherwise to division, multiplication, addition, and subtraction. It's 2 times 40, 80. 80 plus 15 is 95. 95 times 15 pi. Let's see what the calculator has. 95 times 15 is 1425. 1425 pi. If the examiner asks you to express in terms of pi, otherwise this is going to be in decimals. So 1425 times pi times 1425 is 4476.769. 4476.769, which is this is in centimeters, so our area will be in square centimeters. Correct to three significant figures, however, this is going to be 448, 1, 2, and the third significant figure, and that's it. So we've done the first three parts so far, and they are quite straightforward, except for the first one, where you have to be cleverly playing with this surface area formula. The surface area of any prism can be determined using this, but you have to be smart which areas are to be included and which are not to be included. Up next is part D. If a manufacturer uses 4,000 square centimeter of tin plate to make a bin with base radius 20, and how long will the height be? So I guess the same formula has to be used, except for our new information for part D is that the total uh, area to be used is 4,000. So 4,000, and it has to be having a radius of 20. So I'll replace R with 20, but the height has to be determined. So I'll keep the height as H. And from here onward, it's simple algebraic manipulation. So something multiplied, this is our subject. I'll put it in red. Our subject needs to be alone. So whatever is multiplied, I'll divide both sides by that. And which cancels out. 20 pi and 20 pi cancels out. Here we have 4,000 over 20 pi, and you're left with 20 plus 2h on this side. Again, our subject h is not alone. It's having an addition of 20 in it. So I'll subtract 20 from it. The inverse of addition is subtraction. And that's what you get. Furthermore, now you have 2h is equal to, if I can cancel this as well, it's 200 over pi minus 20. And since 2 is multiplied with h, I'll divide the whole of this. I'll divide all of this right and left hand side by 2. Let's see what we get. Another trick that I want to share here is that if you're not convenient with writing the over form like 2h over h, I use the division symbol. And it's a clever display. Sometimes it helps to understand the division of so many terms in one place with the help of division symbol instead of writing as a bar. It makes much more sense and meaning. Finally, our subject H is on one side, and we are now going to do all this calculation in one go using the calculator. So it's bracket 200. Let's make it a fraction first. So it's fraction um, 200 over pi. Whatever this answer is, I'm going to subtract 20 from it. Whatever this answer is, I'm going to divide by 2. And this is my final answer. H is 21.8 centimeters. So for a bin which has surface area 4,000 square centimeter and radius 20, the height should be 21.8. Now, in all this process, more than anything, you use the basic skill of changing the subject. Change the subject. How you change the subject? First of all, you need to make sure the following criteria that you need to fulfill for the subject. Number one, it should be alone on one side of the equality. Number two, it should be positive. Number three, it should be in the numerator. And number four, it should have power +1. All right. So this is the criteria that we meant here. It's alone on one side, it's positive, it's in the numerator, and it has power +1. Moving on to our last part for the question. Make H the subject of the formula, this. So you can see here, whatever we did in part D, we now are going to do it without any value. It's all going to be in terms of R, H, pi, and V. So keeping this formula, V is equal to 2 pi R H plus pi R square, and making H the subject, we should have this. Let's start with H. If H is our subject, whatever term is on that side, we'll do the inverse operation. So it's V minus pi R squared is equal to 2 pi R H. And then H is still not alone. Whatever is multiplied with it, we will divide both sides by that 2 pi R. So it's cancelling out. H is equal to V minus pi R square over 2 pi R. And lastly, we are also directed to use this arrangement to check the answer in D. So if volume is 4,000, what's the height? We have worked out the height manually first. It's 21.8. The volume is 4,000 and the radius is 20. Let's verify. Volume is 4,000 minus pi times the radius 20 squared over 2 times pi times 20. I'm going to use the calculator. 4,000 minus pi times 20 squared will be 400, and then all of it is divided by 40 pi. 2 times 20 is 40. This gives us 21.83. 21.83, which is 21.8, correct to 3 significant figures, and which is the same answer as we obtained using the calculations. Hence, our formula, our working is verified. Important to note is, check your answer with D. We have to use the working or the result in D. It's very important for us. So that is it for this question. It used a lot of algebraic skills. And surface area. For surface area of prism, that's the best way. You just need to remember this one equation and you can do much working for almost all the prisms. don't need to memorize different formulae for cylinder, different formulae for cuboid, and etc. You just remember one way of finding the surface area, and that serves in most of the cases. Thank you.